Okay, in this video I'm going to go through a application-based problem, which I would consider to be a mixture problem. So in your notes at the top, if you want to label this lesson 2.3b, application, problems, and again we're looking at mixture problems in this video. And so I'm going to be going through one type of problem, and then I'll give you another with another video link so that you can check your work to that problem. So the problem that we're going to be going through is as follows. A radiator contains 8 quarts of fluid, 40% of which is antifreeze. How much fluid should be drained and replaced with pure antifreeze so that the new mixture is 60% antifreeze? Go ahead and identify what is this question asking you to do. Okay, and the answer to that question is I want to figure out how much antifreeze should be drained and replaced. And so this is answering the question, how much antifreeze? And so in the end, since I'm given my units in quarts over here, my answer should look like some number and then quarts. Go ahead and now take a look at the question. What does the problem tell you? Okay, so this problem tells you a couple of things. Hopefully you got all of these. If not, take a look back at the problem and make sure you can identify them for yourself. So the first piece of information that I'm given is that my radiator contains 8 quarts of fluid. So my radiator has 8 quarts of fluid. And I'm told that 40% of that is antifreeze. 40% antifreeze. 40% antifreeze. And then I want to figure out how much fluid should be drained. So if I'm draining the fluid, it's going out. And replaced. So if it's replaced, then I'm going to be back to 8 quarts of liquid. If it's being drained, so it's going out, and then I'm replacing it with new antifreeze. So in the end, I should have 8 quarts of fluid. And I'm replacing it with pure antifreeze. Go ahead and take a moment. What does pure mean to you? And so in this problem, when I say pure, this means 100% antifreeze. So it's not drained down with any water or any other fluids. It's just antifreeze. So I'm filling it with 100% antifreeze, so that the new mixture is 60% antifreeze. So new mixture is 60% antifreeze. Okay, so this is all the information that I can get from this problem. What I need to find is how much antifreeze I'm draining and replacing. To start this problem off, I'm going to put a visual to the problem. So I'm starting off at a 40% solution that is 8 quarts. 8 quarts, 40%. And from that, I'm draining out, so I'll draw a drain, there's some liquid coming out. I'm draining out some number or some amount of liquid. So if it's draining out, I'm taking away some amount of liquid. I don't know what that is. And then to it, I'm adding some amount So I don't know what amount. I'm not going to draw a water line, or I could draw this water line here. Some amount of 100% antifreeze. So that in the end, I've got a 60% antifreeze solution that's back at my 8 quart line. So I've got a 40% mixture. I'm taking away some amount of it and replacing that amount with 100% antifreeze to get a 60% solution. Go ahead and right below this, I want you to brainstorm an equation that you can come up with to describe this picture. Take a guess. You're going to be dealing with percentages. So think about in a problem, in a mathematical problem, when I'm dealing with percentages, what do I have to do with those percents? Try something. So one thing that I can try to do to solve this problem is I can take my percentages and I can turn them into decimals. So this is really 0.4, and this is really just 1, and this is really 0.6. So I've got 8 quarts here, and I'm taking away X amount of quarts. So I'm going to put that in parentheses because it's dealing with the same units. I'm starting off with 8 quarts, and I'm subtracting some amount from it. Here, I'm just adding some amount. So I've just got an X in terms of my quart, and here I've got 8 quarts. When I'm taking a percentage of a number, so if I've got 60% of this 8 quarts as antifreeze, percent of a number, what do I do with my 2 values? That's right, so I multiply these 2 values together. So 60% of 8 quarts, I'm taking 0.6 and I'm multiplying them with 8. So if I've got 40% of 8 quarts minus some amount of quarts, I'm going to multiply these 2 terms. So I've got 0.4 times 8 minus X quarts. And here I've got 100% times some amount of quarts. And now I've got my equation. There's nothing that I'm not considering up here that I'm forgetting about up here in my equation. So I can go ahead and solve and simplify. So I'm going to distribute in my 0.4. If I take 0.4 times 8, I'll end up at 3.2 minus 0.4x plus 1x equals 0.6 times 8 is going to give me 4.8. So then I'm going to just combine like terms. Negative 0.4x plus 1x, that's going to give me 3.2 plus 0.6x equals 4.8. Then I'm just solving for x. So I'll subtract 3.2 from both sides. I'll end up at 0.6x equals 3.2, or 4.8 minus 3.2 is going to give me a 1.6. And then lastly, I'm going to divide by 0.6 so that x is equal to 2.666 repeating quarts. So if I look back up at the original problem, or at the equation that I set up, x in this problem represented the amount of quarts that I'm draining from here and then replacing over here. So I want to go back up to what is this question asking me to do. And I'm finding out how much antifreeze I'm draining and replacing, and my answer should look like some number and then quarts. So if I ask the question, have I answered this whole problem? The answer to that is yes. I've got my sum number and then quarts. The last thing I want to ask myself is, does this answer make sense given the rest of this problem? Well, my total amount is 8 quarts. I know that has to be true. So I know that this number should be some amount less than 8 quarts. Some amount less than 8 quarts. And so far it makes sense, yeah. If I were adding 7.99 quarts, that wouldn't really make sense because I'm taking 100% antifreeze. That's like taking like a lemonade concentrate, you know, those little cans of lemonade that you can get and just add water to, and they're frozen. That would be like taking that whole thing and just putting that and saying, okay, everybody drink this lemonade that's just 100% concentrate. And so it makes sense that it's a pretty small decimal, but not something that's just not even worth our time, something that's way too small. So I would say that this number makes sense, and that's going to be our final value. Go ahead and you're going to solve number 4 in your problem set. So for 5th period and 2nd period, this is the problem that you should be solving within your problem set. If you are in 3rd period, you've got a different set of problems, but this one will also help you. Once you finish this problem and you've entered in your answers, there's going to be a video link that pops up at the end of this Edpuzzle video. Make sure that you watch that video if you're confused as to how to solve this problem. You want the correct work along with the correct solution, so that should help you solve the last problem in your problem set.